What's up, everyone? Today's course is going to be a computer science degree in six minutes. All right, let's go. So the computer science degree is basically a ground-up education of how a computer works. And the first thing that you learn about computer science is that everything is layered on top of everything else. You start with the very basic circuits, the NAND gates, and you can use those NAND gates to build any other kind of circuit imaginable. And then on top of that, you put an assembly language, and on top of that, you put another language like C, and on top of that, you put more humanly readable languages like Python, and then you build frameworks on top of that, and everything is layered, until you get these incredibly complicated applications that you can break down into tiny chunks and have these like atomic steps to build infinite complexity on top of. Programming is going to be one of the hardest things you ever learn how to do, and it's going to be super frustrating. You're going to want to give up, and a lot of people in the computer science course give up when they realize that they don't know how to do programming, and they think it's too hard for them, but it isn't too hard for them. You just need to practice. You're going to learn about things like variables, $x equals 5, and now your computer program remembers that there is a variable called x and its value is 5. You're going to learn about stuff like functions, which are just code that you can run multiple times without having to write out every step every single time you want it to happen. And then you can see at the bottom, this is the function working. You're going to learn about all the different mathematical operators like plus, minus, divide, and something called modulo, which takes the remainder of a division. And you're going to learn something called classes, which are basically just variables and functions grouped together and then called a more general name. And it's just a way to abstract ideas in code without having a messy spaghetti code. You have more of like a hierarchy of code where it's more easy to understand more quickly. And that is an object-oriented approach to programming. Now, if you've made it this far into the video, make sure you hit the subscribe button, because I do videos like this all the time, and I can show you how to be a computer programmer and how to get the software development job of your dreams and have a great software development career. So make sure you hit that button, and let's continue with the video. Now, this is where it gets interesting. You're going to learn that not every algorithm performs at the same rate of efficiency. There are algorithms that do the exact same thing as others, but they do it orders of magnitude worse or orders of magnitude better, and that can be the difference between making beautiful, maintainable, scalable code that can work in the real world and grow and become a fantastic use for everyone out there, or make terrible code that never works optimally or performs very well at all. And it's all to do with algorithmic complexity. When they teach you about algorithmic complexity, they're going to talk about something called Big O notation. The Big O notation is a way to mathematically describe how efficient your algorithm is and how many steps it takes to complete your algorithm versus how many data points there are that need to be sorted or dealt with. While you're learning about computational complexity and algorithmic complexity, you're probably going to learn about two sorting algorithms. There's bubble sort and quick sort. Now, quick sort has a big O complexity, otherwise known as a worst case complexity, of n log n, which means if there are n number of things being sorted, the amount of steps required to sort them in the worst case scenario is n multiplied by log n. So if there are 100 things to sort, it's 100 multiplied by log 100, which is 100 multiplied by 2, which is 200. But with bubble sort, worst case n squared complexity. So the amount of steps required in the worst case to sort a list of 100 using bubble sort is 100 squared, which is 10,000 steps, which is a massive difference in computational complexity. Binary and hexadecimal numbers are like the underpinnings of how the computer hardware thinks. On the one hand, you're going to learn about hexadecimal, which is a base 16 number system, and that means the numbers go from 0 to 15, so there's 16 of them. And then there's binary, which is a base 2 number system, which means you only have 0 and 1 to work with. And from 0 and 1 in binary, you can make any number you like as long as you have a long enough string of ones and zeros. And the same goes for hexadecimal. If you have enough 0 through 9 and A, B, C, D, E, and Fs, that's all the numbers in hexadecimal. If you have enough of those, you can represent any number using those. Hexadecimal numbers are important in computer science because they describe how memory addresses work. And once you know where memory addresses are, you can put things into them, you take things out of them, and then you can create entire programs while ordering your memory addresses in a certain way so that you can traverse them easily and write programs around that structure. Operating systems and computing architecture is one of the more intimidating courses that you're going to take in computer science. You're going to learn that the von Neumann architecture, which is the architecture of all the computers that we use today, is based from a very old architecture that we've been using for a long time. And you're also going to learn something called the Unix shell and a few of the different command line tools that operate the Unix shell and are going to make your life easier as a programmer. So thank you very much for watching this video, and hopefully you learned a little bit about what it's like to do a computer science degree. If you like this video, make sure you check out my free ebook. The link is in the description. And if you really like this video, consider checking out my buymeacoffee.com. It really means a lot to me for those of you who support me doing that. So thanks again for watching. Please subscribe, and I'll see you in the next one.